Right, so today we're going to talk about writing linear inequalities. Okay, so the past couple days, been writing single variable inequalities where it's just x is greater than, less than. Okay, so now we're putting the y in there as well. So these are fairly simple in my opinion. As long as you're able to graph a linear equation, you can't, and you're not going to have a good time here. Okay, so it's kind of broken down into three different parts here. First part is you're just basically going to graph the line. A second step is determining whether or not you're going to use a solid or a dashed line. So notice if it's less than or equal to, greater than or equal to, that's when you're going to use a solid line. If it's less than or equal, if it's less than or greater than, it's going to be a dashed line. And then the third part, I guess I've written that here, is that you are going to either shade above or below the line. Sometimes it's hard to tell the more vertical a line gets, what's above and what's below. And we'll talk about that. Okay, but if it's y is, I don't know why I put those around. If it's y is greater than or equal to, or just y is greater than, you're going to be shading above. If it's less than or equal to, or just less than, and then you'll be shading below. All right, so in this example, we have y is greater than or equal to 2x minus 3. So I start with my y-intercept of -3. And I have my slope of 2, which means if I go up 2, I go to the right 1. Up 2, right 1, up 2, right 1, or down 2, left 1. Okay, so now we need to figure out if it's going to be a solid or a dashed line. Okay, since it's greater than or equal to, Easy way to remember, it's got a solid line underneath it. That means you should be drawing a solid line. Pretty simple. All we've done so far is graph the line y equals 2x minus 3. Okay, and so now the last part is we are either going to shade above or below that line. And what we're signifying when we do that is that all of the points in the shaded region will make this inequality true. Since it's y is greater than or equal to, means we're going to shade above this line. Again, sometimes difficult to tell. Okay, but all of these points, okay, that fall in this shaded region should make this inequality true, or will make the inequality true. All right, and that's pretty much it. Okay, again, if you can graph a line, you're in a pretty good start. If you don't know how to graph a line, it can make it a little difficult. Okay, it's always good to kind of test a point as well, okay, to determine if you've shaded in the correct region. All right, so what do we think would be the easiest point to test? Anybody have an idea? 0, 0, right? So we can always test 0, 0. Okay, if we take a look at our graph, is 0, 0 in the shaded region? Yeah. So when I plug in 0, 0, I should get a true statement. Plug in 0 for y, 0 for x, and I get 0 is greater than or equal to -3, which it is. So 0, 0 should be in the shaded region. All right. Let's do another couple examples. Y is less than -1/3 x plus 1. Again, we start to drop our line. Y-intercept at +1. Slope of -1/3 means if we go up 1, we should be going to the left 3. or we go down 1 to the right 3. Okay, so we ask ourselves, is it a solid or a dashed line? There's no solid line underneath our inequality. Okay, so that means we want to make a dashed line. Like so. We got our dashed line, y is less than negative 1/3 x. So less than means we shade below. Whenever we have fractions like this, it's a lot more clear which is above and which is below. Okay, still below the line. Okay, all these points down here. Okay, so you might get asked a question that's something like this. All right, asking is 3, 0 a solution? Okay, 3 zeros right there. It's on the line, but the line is dashed. Okay, it means we are not including that point. Okay, you could also plug it into your equation and you get, or your inequality. And when you do so, you get 0 is less than 0. Which last time I checked, it is not. So this is false. Which means 3, 0 is not a solution. All right, try this one on your own real quick. Y is greater than or equal to 1/2 x minus 5. All right, so start at -5. 1, 2, 3, 4, 5. Slope of 1/2. A solid or dashed line. Solid, very good, thank you. Shading above or below? Above. Okay. Now what I want you to do on that same set of axes, I want you to graph. So on this exact same graph, the first, whatever one you drew, I want you to graph y is less than -4x plus 1.
Two sets. I hate all my.
All right, so
I hate all of it.
graph it on the same one. We start at +1, slope of -4.
There's no filter on that. Let me see. There's no filter on any. Let me see. They're all unedited.
Solid or dash line? Dash.
I don't know where all my pictures are.
Shading above or below. Should be below again. The more vertical it gets, the more difficult it kind of is, but it should be over here.
Oh, I like them.
Okay, like that. So my question is, if I turn this into a system of inequalities, okay, where do you think my solutions are for both of these? What would my solutions be that fits both of these?
Like that.
Yeah, in the region where they're overlapped. Okay, in that area. Okay, so any point in this area will satisfy both of those inequalities.